Okay, this is, so the book titles it Net Change is the Integral of a Rate. Well, right? Here's what it is. If I give you a problem with position, velocity, acceleration, right? Which one of those is a rate?
Velocity.
Yeah, it's velocity. This is your rate, right? Okay. How do I get back to position? Yeah, that's what we're doing today.
Okay.
Yeah, right. So basically, we're studying integrals in context of real-world problems. Okay. So we're thinking a car is traveling at so many miles an hour. What was the position change? How far did it travel? Or we're thinking blood is flowing at a certain rate. Okay. How much blood has flown during that time period? So all sorts of problems where I can give you a rate function in a graph or a table or something, and you can calculate position change. Okay. Good on that? Can I give you the big picture? All right. So basically, you remember how we note these, right? This is the derivative, which is velocity, right? And this is the second derivative. Okay. All right, so basically what we have here is some integral from A to B of a velocity or a rate, right? If you're in context, what would that equal?
F or ST.
Right, S at T from A to B, which is also
Big BT.
nope. Just evaluate it. That's all this means. You betcha, Jason.
Is it SMT? Because that's the
Yeah. Yeah, so it's the same, it's the fundamental theorem of calculus. That's what this is. We're just applying it to velocities. Good?
Does that include the entire alphabet?
Oh, sorry, I was.
Not just our alphabet, Greek alphabet too.
I just like it how you've gone to the point
Okay,
of
let's
right
move on. Okay, sometimes, so I put A and B here. Sometimes the problems will include times, right? Time 1 and time 2.
Okay.
The velocity of the car from time 0 to time 5 was 50 miles an hour. How far did it travel? Right, so you could put time 1 and time 2 as indicators here as well, okay, just to be more contextual. All right. Good? All right. Sure. Okay. I'll take that as a yes,
Yeah, good.
even though I think it means no.
Examples?
Yeah, so,
No, whatever, not gonna get any.
How dare you on examples?
I really don't like
oh, that's funny. Okay, let's say have you guys ever seen the movie Uncle Buck?
Yeah.
Anybody here ever seen Uncle Buck?
Wow.
Oh, it's a classic comedy. Guy shoots the hair off of a grizzly bear's butt with a shotgun. Okay. Right? Well, he's a giant feller. He's really big. And Uncle Buck, let's just say Uncle Buck's at your house and he sits on your toilet and it cracks. Okay, and water's leaking from your toilet.
Okay. Doesn't he ball the bear's butt?
At a rate?
Great outdoors.
Yeah. Okay. 2 plus 5t liters per hour. Okay. So your bathroom floor is getting wet and it's nasty. T is the number of hours.
Is that ST?
Two.
2 plus 5t.
Okay.
Okay, T is the number of hours after 7 a.m. And that's when he sat on the toilet.
Oh, dang.
Had to do his morning business.
You're so happy.
Right? Okay. How much water is lost? From 9 a.m. to 11 a.m. because Uncle Buck was really irresponsible and didn't tell you that he broke your pooper. Your latrine, your John, whatever. Oh, all right. That right there. This is probably the main way you're going to have to identify these problems. Liters per hour is a rate, right?
Right.
Okay, so we have to know that that is a rate. Okay, what are we asking for? The amount of water that leaks, right? It's a,
12. So you do.
okay.
Evaluate.
This is basically a position change. Okay. So you have to interpret those, right? So what function are we going to use?
So 2 to 4.
Yeah, 2 to 4, because 9 to 11, right?
Right.
And
And it equals 2
2
plus
plus
5
5.
t.
dt. Very nice.
Wait, what's form two?
So you're very happy because your big fat uncle has caused you to do calculus.
Yeah, what's the two?
T is the number of hours after 7 a.m.
Oh, and
7
then
a.m.
9
is
9
time
hours.
0. So 9 a.m. is
Time
time 2, and 11 is 4. Okay, very nice. Good questions. All right. I know you can figure that one out.
10.
Have at it. Yeah, what's the antiderivative, Jason? What's the antiderivative of 2?
2t over 2.
2.
2t
It's just 2t? Oh,
Yeah, you just add the variable.
over 2
Evaluated from 2 to 4.
to 4.
All right, let's see how what your bathroom got. 2 times 4 plus 5 times 4 squared over 2.
Minus
And 2 times 2 is 5 times 2 squared over 2. Now you can shorten that up if you want. I write it that long way so there's still some of us that are a little confused on this, so we see where they go. 48.
Ow. You get 48.
That 8 plus, and then 4 squared is 16, times 5 is 90 over 4 is 45, 2 times 4 is 8, 8 plus 45 is
44.
16 times 5 is 80.
80.
but divided by 2 is 40.
I can math.
Yeah. Well,
This is 4 plus 14, right?
yeah.
So we get 34 liters.
Dang.
So take your Nalgene bottle and dump 34 of them on your bathroom floor. That's how much poo water's on the tile.
How'd you get 40? Yeah.
Okay, 2 times 4 is
8.
8. 4 squared
16.
divided by 2
8.
times 5. 40.
Wow. That doesn't
So
break 10 bucks?
you could, no, because multiplying and dividing can be done in any order. No,
Oh,
no,
yeah,
it
it's
can't.
still 40.
Can't say that.
Even if you do this.
Yeah, no, you have to do multiplication then division.
Which is
Multiplying can be done in any order. So that's all you've done is move the multiplication. It works. Trust me.
It's not gonna work.
Plus now I'm a doctor.
How many gallons is that?
A lot.
Yeah.
No, it's more than 3 gallons.
What's 4 into 4?
34
Is there any gallons?
divided by 3.78.
There's like 10.
Oh, let's make this the science problem. Liters
Oh.
We want to get gallons, right?
No, stop.
1 gallon is 3.78 liters. But top and bottom cancel.
Yes.
He's such a goon.
8.9.
You called me a goon?
Yeah.
Goon.
It's like nine.
An absolute
About 9.
goon. A goon?
How is that any different from what you did?
Okay. It's not.
Okay.
But this is like,
Science.
this is a science way and it's really confusing, right? Sometimes.
I don't like
What do they call this? That big bad word, stoichiometry?
Yeah. Oh, stop.
I just threw up a little in my mouth. I hope you're happy with this.
It's a good thing lunch wasn't 10 minutes ago. All right, anybody know that's
8.994.
981.
Oh, is it?
okay, whatever. Okay, so there's 9 gallons of poo water on the floor. Very, very nice. Thank you.
No, not very nice. Because that's 8.9.
Okay. Again, here's another one. Let's talk about traffic flow. Okay. This is actually something that the Department of Transportation would do. Okay.
No.
That'd be way better.
Okay, cars per hour. Oh, should your alarm bells be ringing? What is that? That's a rate. Yep, yep. So if I were reading this on a free response, I would be like, woo, rate. And I get so excited that I have 3 exclamation points. Passing an observation point. Is called, okay, we're getting technical, traffic flow rate. Yeah. We're going to call this a function Q of t. That's what it says. So. Okay. All right, so that's some info, right?
He's just a number.
Here's a question you'll get on a free response. Explain the meaning of this integral.
That's just the rate.
It's the integral of rate. Yeah, so what does that give us as an output?
Position.
Yeah, in context of this problem,
How many cars
will
go
pass?
through there per in and out?
perfect. Yeah, so what you might write is the integral from t1 to t2 is
The amount of cars that pass during that time period.
the number of cars passing, what's it passing?
That's the
Observation.
The observation point.
During the time period.
What time period?
From T1 to T2.
Or from t1 to t2, or on the interval t1, t2, lots of ways to write it. You can write this sentence 10 different ways.
Only
The key is that your subjects and your verbs and your adjectives are all in there properly. They're looking for this. Identify that, and that. Okay?
You have to write it out in
You should put that in there. Okay. If I said it, is there any way that I can misinterpret if I wrote it here?
Yes.
How can I misinterpret it?
Because it could be the number of cars, the time
It could be-
period, the interval.
It could be the function.
Flow rate.
Observation point.
It could be the integral of the function, right? So we do not want to use those types of words, okay?
Do you want this to solve, I'm guessing?
Yeah, we're gonna do a table. So
How nice. Tables are nice.
let's estimate the number of cars
Okay.
passing the observation point using a left Riemann sum.
No.
With, let's go with 4 subintervals. And then we're going to give you a data table. So let's say from 7 a.m. to 8 a.m. Since we're specific.
Hooray.
Yeah, pretty much.
15 minutes.
See? Good. 7.
Cool arm.
And one more. Your book has till 9 o'clock, so we're just going to shorten it up a little bit.
You got 1844 or 1856?
44. Okay, so
That's a lot of cars in 15 minutes. That's a highway.
this basically tells you what to do, right? Yeah, left Riemann sum. So that's what you're going to do. So how do I calculate a left Riemann sum here?
1,044 times a quarter plus 1297.
Yeah, how much of an hour is this? It's a quarter of an hour, right? So
Plus 1297 times a quarter plus.
yeah, so you've got your rectangle height and your rectangle width.
Wait, can you just add them all? Because they're all the same interval. Can you just add them all together?
Yeah, you could do that. That's easier, definitely. Am I done?
No,
Yeah.
you gotta do it.
Yeah.
Yeah, you're
Oh, it's
done.
never our cue, yeah.
Okay, we're gonna finish it because we're in class.
Oh.
Could you also write it this way?
Yes.
Yeah.
Yeah, much easier, right?
Yeah.
You save.
Thank you for that suggestion. I believe it was Kendra. So how many total cars?
A lot.
1,300 something, I bet you.
1,415.
Dang, I was close.
Well, 1,416, because you can't have 3/4 of a car.
What about a motorcycle? What would that count as?
That's it.
It'll count as a car, vehicle. Oh, okay. Sometimes the question will say include units.
Cars.
Hours per,
Yeah.
per 15 minutes.
So if the question says include units, you're earning a point on that. Okay, so all right, again, we have a rate function. We've approximated it with we've approximated the number of cars with a Riemann sum. That's an integral, right? It's just an approximation. So, integral of a rate is the change in whatever you're asked for. Cool?
Yeah.
Bueno. We'll look at a few more problems tomorrow. Displacement and distance traveled is the big one tomorrow. The difference between the two.
Yes. Well, then David would have just.
No. Hey, Kendra.
You actually take notes?
Hey, Kendra.
No, he doesn't.
Damon?
No, I take notes all the time, thank you. I just take the notes that I feel are necessary to take. There's a difference between writing down the entire lecture and breaking down the notes you draw.
Stop it.
It's a sign from
Stop
God.
right there.
It's a sign from God.
What?
He doesn't want you to write.
Due tomorrow.
I almost.
Ah,
9 problems.
okay.
And they're all even, or odd.
All 15.
Life is amazing.
I'm assuming that's a 15.
15. I was looking for a basic understanding of integrals of rate is net change. You'll have a quiz tomorrow, so.
Oh, that's really good.